Guys, welcome to section 8.2, day 1. Today we're going to talk about the law of sines. And you guys know SOHCAHTOA. We know that really well. SOHCAHTOA and Pythagorean theorem are only good when you have right triangles. So what do we do when we don't have a right triangle and we're trying to find missing sides and angles? Well, one of the ways is called law of sines, and the other one's called law of cosines. So today we're just going to focus on law of sines. And here's what it is. It's actually really easy to use. It tells us that the sine of an angle over its side is equal to the sine of a different angle over its opposite side. And you can pick any two of these to just cross multiply and solve. So it kind of depends on what you have. Now, law of sines is good. If you guys think back to geometry, when you have ASA or AAS or SSA, that is when law of sines works well. And then, I don't know, probably in a couple days we're going to do law of cosines. That works well when we have side angle side or side side side. Okay, so these are really the three cases where law of sines works well. Okay, let's try it. So really easy to use. If you need to draw a picture, totally fine, but I'm going to try to do it without a picture here. So I would start by finding a letter where you have both its angle and its side. So see how we have angle A and side A? That means we probably want to use this ratio here, right? So I'm going to do sine of angle A over side A, and that's going to equal, and then just use the other letter that you have. We have angle B, so let's do this one. Sine of angle B over side B. And then that's how we'll know what we're going to solve for first. Okay, so it looks like we're going to solve for side B first. All right, so we cross multiply to solve. And it's going to be, you're running out of room here, sine of 40 times B equals sine of 60 times 4. And then if you're trying to solve for B, we're just going to divide both sides by sine of 40. Divide both sides by sine of 40. All right, so these cancel, and we'll be able to get B. All right, so to type in, we are in degree mode, so make sure you're in degree mode. We're going to do sine of 60 times 4 divided by sine of 40. Okay, and then I'm just going to round to one decimal. This is going to be about 5.4. Okay, and then we need to find, let's see, angle C and side C. Okay, so to find angle C, that's going to be really easy because we know that three angles in a triangle always add to 180. So if you do 180 minus these guys, 180 minus 100 is 80 degrees. Okay, and now I think the only thing missing is side C. So I would use the ratio that we started with again, and now we're going to use that with the C to find side C. Okay, so now we need another proportion. It's going to be sine of 40 divided by 4 equals sine of 80 now, which is angle C, divided by side C. And then again, let's cross multiply in order to find side C. So it's going to be sine of 80 times 4 equals sine of 40 times C. And then to solve for side C, we'll just divide both sides by sine of 40. And these cancel, and we'll be able to get C. So sine of 80 times 4 divided by sine of 40. And then you guys hopefully get C equals 6.1. And then I think we have everything we need. Okay, so solve the triangle means find everything that we didn't have to start with. All right, let's try it again. Number 2. And then this one, why don't I draw a picture for this one in case I lost anybody on that last one. And this picture is going to be terribly not drawn to scale, but don't worry about it. A, B, C. And then this is side A, side B, side C. Okay, so we're given angle A is 35, angle B is 15, and side C is 5. Okay, so that's what we're given. And we just need to find everything else. So in this one, how about right away we just find angle C? So it's going to be 180 minus 35 and 15. Oh, you can't see that. And that's 130 degrees. Okay, so we probably want to do that first. Okay, now can you guys find a pair where you have both the angle and the side? And you would say, oh, C, right? We have both the angle and the side, so we definitely want to use the C's when we write our first ratio. So it's going to be sine of 130 over 5 equals, because those are our C's, and then your choice if you want to find A's or B's first. I'm going to do A, and then it's going to be sine of 35 over A. And then just cross multiply. And we have sine of 130 times A equals sine of 35 times 5. And then you guys know if you want to solve for A, just divide both sides by sine of 130. So these cancel, and we get A. So A is going to be sine of 35 times 5 divided by sine of 130. Okay, so A is going to be about 3.7. And now we need to find side B. So we're going to set up another proportion. I'm going to stick with the C's, and then I'm going to do the B's. So sine of 130 over 5 equals sine of 15 over B. So stick with the one that you have both of, and then just do it 2 different times to find A and B. All right, so if we cross multiply, we get sine of 15 times 5 equals sine of 130 times B. And then obviously to solve for B, we divide both sides by sine of 130, and then we can get B. Okay, so in the calculator, do it over here, it's sine 15 times 5 divided by sine of 130. And that is about 1.7. And then I think we found everything we need. Okay, moving on. Let's do one of these, and then how about we save the other one for class when I see you guys next. Okay, so number 3. Let's see if we can read this story and solve it. Okay, so to measure the height of a mountain, a surveyor takes 2 sightings of the peak. And they're 900 meters apart. The first one, he has to look up, he or she, at an angle of 47 degrees to see the peak. And the second one, they have to look at an angle of 35 degrees to see the peak. And the transit is 2 meters high. What is the overall height of the mountain? Okay, so technically, we need this whole thing to the ground level. That's the height of the mountain. Okay, but we want to use right triangles to find some stuff, and then we can just add that in later. Okay, because remember, this is just 2. So if we can solve for the h in the right triangle, we can just add 2. Okay, the problem is we don't have enough numbers to do, it's a right triangle, so that's good, but if we use the 47 with the h, we don't have a number here or here, so we can't do SOHCAHTOA. And then if we use the 35 for this big triangle, we have the h, But again, we don't really have an adjacent side. We only have a 900. So we have to use a system on this problem because we don't have enough numbers to just do one SOHCAHTOA. Okay, so here's what we're going to do. Why don't we call this x right here? And then why don't we call for the big triangle, this whole length would then be 900 plus x. Okay, so here's what we're going to do. We're going to set up two, kind of like a system of SOHCAHTOAs here. And let's start by setting one up for this blue triangle. Okay, so for the blue triangle, we have the height would be the opposite, and the x would be the adjacent. So with an O and an A, let's do tan. Okay, so tan 47 equals h over x. Okay, that's going to be for our 47-degree triangle. And now let's do the same thing for the 35-degree triangle. Okay, so that's this big one. So for this big triangle, we have the angle 35. We have the opposite being the height, and the adjacent being the 900 plus x. Because we can't just use the 900 if we're using the big right triangle. Okay, so tan 35 equals h over 900 plus x. Okay, so those are our two triangles. We can't actually solve this, but what we can do is solve for h in both of them. So if you cross multiply, do you guys agree that h would be x times tan 47? And in this one, h would be 900 plus x times tan 35. Okay, so we just cross multiplied. And now if h equals this and h equals this, then why don't we just use a little substitution and just set this equal to this, since they both equal h. So now we have x times tan 47 equals 900 plus x times tan 35. And now we just have to solve for x. Okay, so instead of getting decimals, I'm just going to save that for later. Let's not do anything in the calculator. Let's just try to isolate x. So it's going to be x tan 47 equals, we're going to have to distribute here, which isn't going to look pretty, but doesn't matter. It's 900 times tan 35 plus x tan 35. Okay, we just eliminated the parentheses by distributing. And now if you have x's on both sides, we're going to want to subtract one of them over to get both of the x's on the same side. So now it's x tan 47 minus this guy, x tan 35, equals 900 tan 35. And then you guys, I hope you know better than to just subtract these two angles. What we need to do is factor an x out. And if you factor an x out, you have tan 47 minus tan 35. Don't be illegal here. And then we still have equals 900 tan 35. Okay, we're almost done. If you want to get x alone, we just have to divide both sides by tan 47 minus tan 35. Okay, and that's going to be x. Okay, so now we can actually calculate this. Okay, so make sure you're in degree mode. I'm going to make a fraction so I can just type it in without worrying about parentheses. 900 times tan 35 over tan 47 minus tan 35. Okay, so that gets us, x is about 1,693.3. Okay, but that's just x. We need to find the height of the mountain. So let's go ahead and plug this in to either one of these. I would say this one maybe looks easier. So if we plug x in, let's cross multiply to get the height. Okay, so the height's going to be this 1,693.3 times tan 47. Okay, so now, wherever we have room here, h is going to be 1,815.86. But remember, that's only the height of the triangle. Now we just need to add 2 to get the height of the whole thing. Okay, so if you add 2, the total height's going to be about 1,817.86. And that is in meters. Oh, you couldn't see any of that. There you go. Okay, nice job, guys. Why don't we, if you want to try this one, go for it. But why don't we do this one in class next time? All right, thanks for watching.